Factoring level 12, find the solution set of this equation. It's a second degree equation. When we go to factor it, we're going to find that doesn't factor nicely. Rearrange it. I put the negative 49z squared first, so in decreasing order of degrees, z to the power of 2, z to the power of 1, and then z to the power of 0. I notice that each of these terms is divisible by 7. Because the first term is negative, I've divided each term by negative 7. That gives us 7z squared minus 12z plus 1 is equal to 0. I'm looking for the factors of 7 that are going to add up to give me negative 12. Since 7's a prime, it's only 1 and 7. I'm not going to be able to think of one. This is not factorable in the regular sense. I'm going to try completing the square. I'm going to get rid of the a term. I'm going to divide each term by 7. That gives me z squared minus 12 7 z plus 1 7th is equal to 0. I want to get rid of that 1 7, so I subtract it from both sides. And we have z squared take away 12 7 z is equal to negative 1 7th. And then we want to find the last term, like a new last term that makes this into a perfect square trinomial. Divide the middle term by 2 and then square it. Take the middle term, divide by 2 and square it. That is negative 12 over 7. So the 2 is multiplying the 7. Divide 12 sevenths by 2. Multiply 12 sevenths by the reciprocal of 2, which gives us 12 over 7 times 2, which is negative 12 over 14. And then I can reduce that. So divide the top and bottom by 2. I have negative 6 over 7. All squared gives us 36 over 49. That's going to be my new last term. I'm going to add that to both sides of the equation to keep it balanced. Now this is a perfect square trinomial. Take the square root of the first term, which is z, sine of the middle term, square root of the last term, 6 over 7, and then test, like is 2 times negative 6 over 7 times z, is that negative 12 sevenths z? Yeah, it is. This is a perfect square trinomial. I had negative 1 7th plus 36 49ths. To get them to add together, I needed a common denominator, which is going to be 49. So I multiply the bottom and the top by 7. So that gives me negative 7 over 49. 36 take away 7 is 29. The 29 over 49. I can take the square root of both sides. And that gives us z minus 6 sevenths is equal to plus or minus the square root of 29 over 49. But 49 is a perfect square. We take the square root of the 49, that gives us 7. We have z minus 6 sevenths is equal to plus or minus the square root of 29 over 7. I want to get rid of the 6 sevenths, so I'm going to add 6 sevenths to both sides. That gives us z is equal to 6 over 7 plus or minus the square root of 29 over 7. We have a common denominator of 7, but we can write it as z is equal to 6 plus or minus the square root of 29 all over 7. We can plug that into a calculator. 6 take away 29 square root is equal to, divide that by 7, and that gives us 0.878, which is our first z, so I call it z1. We can also get 6 plus the square root of 29 divided by 7, which is 1.6264521. This is our solution set using completing the square, but we could also do this a lot easier using the quadratic equation. If I go into my quadratic equation calculator, with negative 49, and 84 is the b term, and negative 7 is the c term, and press calculate, we get the same answer. I'm just going to copy this and paste it into as a solution set, and then press enter. And there we go. And that's how you can solve a level 12 type question using completing the square or using the quadratic equation. Have a good day.